So 4-1 to 4-3, it's kind of all here. And so I did mention this before, but percent and the symbol percent just mean out of 100. All right. So whenever you see the percent symbol, you can just read it as 1 over 100 in line. So like if you're doing, if something says 4% symbol, you can do 4 times 1 over 100. And that's exactly what it means. Let me just try this autofocus here. So much better. Autofocus keeps going off. So, and percentages what we're talking about. So for instance, we can kind of go back and forth. So write each decimal as a percent, and each percent is decimal. We've done this before, again, but it's good review. Right. So 0.29, if I want to write it as a percent, I have to just force it to have a 1 over 100. So a lot of you might just know right intrinsically that it's 29%. But if you didn't, what I'm going to do is I'm going to write it as 0.29 times 100 times 1 over 100, right? And so when I multiply it times 100 and divide it by 100, nothing changes, but this 1 over 100 is the percent symbol. And then if I do 0.29 times 100, I have 29%, all right? And you can double check that if you weren't sure. You could bust out your calculator even, if you're so inclined, and do 0.29 times 100. We get 29, and then as I said, 1 over 100 literally just means the percent symbol. So that's 29%. Right. All right. Now it could get a little trickier with things like 1.1%, but it's the same thing. You do exactly the same thing. I can just multiply it by 100 and divide it by 100. And so when I multiply 1.1 by 100, I get 111, right? And again, you can check 1.11 times 100, 111%. All right. So we're not changing anything. We're just rewriting it in a different way. 2/5. Any ideas? What we'll do there?
Could you just add zeros onto it and then double it?
Add zeros
It'd
onto
be
it.
20 over 50, and then it'd be 40
Oh,
over 100.
you are very clever. Yeah, you can do that. That's a good idea. That didn't occur to me. Yeah, so she's saying, so you put zeros, so I get 20 over 50, right? And you can totally do that because the zeros obviously cancel and everything's fine. And you get the original fraction, and then you double it, and she gets 40 over 100. And then she knows that the 100 in the bottom is really the percent symbol. So that's the same as 40 times 1 over 100. And that's the percent symbol. So you get 40%. That's a neat way of doing it. Do that, actually. That's good. I guess I
My
should.
brain works in weird ways.
I guess I should note that that probably won't work if the denominator doesn't have something that you can get to be 100. So for instance, 5 divides 100. But if it was like 3 doesn't divide 100. So you would have a trickier time there. But it's still a neat trick. The other way you could do it would just to use a calculator. So you do just 2 divided by 5 is 0.4. And as a decimal, then you multiply times 100. So you can convert to a decimal and then multiply it by 100. And then you can get, it is a percent as well. But that way it doesn't use calculator. And obviously we know 40%. We just did this one. So it's the same as just 0.4, right? But if you weren't sure of that, what you would do is you just note that the percent symbol means over 100. So it's 40 over 100, all right? And then you just plug that in your calculator. So you do 40 divided by 100, or you would just know it, and you get 0.4, right? So either way you want to do it. But in general, to go from a decimal to a percentage, you multiply by 100. To go from a percentage to a decimal, you divide, right? And so for this one, you just, as I said, you divide. To go from a percentage to a decimal, you divide by 100. So it's 256 times 1 over 100. And if you know anything about dividing and multiplying by powers of 10, you're just shifting decimal places. So in this case here, when I divide by 100, my decimal place is right at the end there. So you're gonna do bloop, bloop, and you get 2.56. Right. Of course, you can divide it on your calculator, and you should get approximately the same thing. I say approximately, but it should be the same. 256 over 100. Oh, thank you, Light. 2.56, as I said. All right. So we've done this before, but it's nice to get a formal review. So let's try some stuff. And most of these word problems rely on this relationship here. So when we're talking about percentages, more often than not, you're talking about percentages in the context of some grand like application. So by definition, percentage is a part over a whole. So for instance, over here, we had 40 over 100. So 40, it can be anything, like carrots. Out of 100 carrots, maybe you have 100 carrots and 40 of them are slightly underripe or have weird knobs on them or something. So you need to disqualify them from your carrot contest. In any case, 40 out of 100 it just means it could be anything, but 40 out of 100 and it's 40%. So part out over the whole. But what's neat is you can rewrite this, right? If I multiply both sides of the part or percent equals part over whole by the whole part, basically I'm going to bring this whole to the left-hand side. I get part equals what? Percent times whole, right? Right, and so if I'm interested in the part of something and I know the percentage that the part consists of the whole or vice versa, I can solve. So if you know the part, the number of parts you can solve, and the percent you can solve for the whole, or if you know the whole and you have some percent, you can solve what part you have. That's basically the strategy for the rest of these examples here. Before we get anything too complicated, let's try a couple short ones. So, all right. 26 students in a class. As I said, think part over whole. 3 of them fail the final exam. What percent of students pass the test? Right. What do we got? Any ideas?
So it'd be 3 over 26.
3 over 26 would be the percentage of students who failed the test.
Oh, pass. So would it be 23 over 100?
23 over the 26. So you can take the number that passed and divide it by the whole. Yeah. So you'll have percent equals part over whole. And so I had 23 pass. And then there are 26 total. Right, so you get 23 over 26. And so there we go. So 23 over 26. And you can round to whatever. I'll do, so it's like 89 because if you do, 6 makes it a 5 and the 5 will make it a 9. It's like dominoes, but it doesn't really matter. I'll say it's 80.89, right? So 0.89 percent passed. But you want to be careful, right? So you don't want to say things like I just said. You don't want to say 0.89% because the percent, remember, means over 100. So to write this as a percentage, what's it going to be as a percentage?
89%.
89%, right? You just multiply it by 100. So later on, too, there's a couple small linguistic things we have to talk about as far as percents go. But that's just one thing to keep an eye on. These are the same things, but when you're talking about percents, you wouldn't say 0.89% unless you're talking about a very, very tiny amount of percent. So 89%. Right. All right, questions there? And you can also find how many failed, right? If you wanted to find what percent failed, you would just do 3 over 26. And then that would give you a decimal, which to get as a percent, you would write it multiplied by 100. So in that case, just to see what it looks like, it should be what, like 11? You can do 3 divided by 26 times 100. Right, and you get just over 11, right? So I rounded this one, so it's tricky to say. Cool. All right, so 1% of Dalmatians are tiny and aggressive. Mine is not. If there are 150,000 Dalmatians in the United States, I have no idea how many Dalmatians are in the United States. How many are tiny and aggressive? How do I find this one? So we kind of use this relationship here. So I want the number of Dalmatians that are tiny and aggressive, and I said it's 1%. And I gave you the whole number of Dalmatians. So we can use this relationship. So I know the percent is 1. I know the whole number is 150,000 and 1, 2, 3. And so I want to find the part. And so I can just multiply the percent times the whole. And when you're doing this, when you're multiplying percents times the whole, a number of things, like the population of Dalmatians, you want to write it as a decimal, because generally most calculators don't accept percentage symbols. Some do. I think this one could. I've never tried it, but in general, just convert it to a decimal. So what that look like? So I have 1% times the population of Dalmatians, which I'm saying is 150,000 and 123. Right? And now we just need to convert this percent into a decimal so our calculator can kind of understand what we're doing. So it's 1 times 1 over 100 times 150,000, 1, 2, 3. Now you multiply it. So put it somewhere. There we go. So I have, and the one multiplied in doesn't do anything, right? It's just a 1. So I get 1 over 100. And when you're doing on a calculator like this, I've mentioned this repeatedly throughout the semester, always use parentheses. So if I did this would be bad. 150, 1, 2, 3, right? I don't know what this will do. Some calculators might say it's 1 over this number, which I think is what this one will do. It didn't, but you always be careful. This is not really a clear statement. It did the right thing, but you wouldn't be certain of that depending on the calculator. So I always like to do parenthesis 1 over 100 and then times 150, 1, 2, 3. All right. Just kind of these small things about calculators, just be careful. In any case, I get about 1,500 just about Dalmatians that are tiny and aggressive. So what is that? I'll just round 150 or 1,501 Dalmatians. Okay. Cool. I should have made this problem saying how many Dalmatians are deaf. That's an actual problem. If you ever get a Dalmatian, many of them are deaf. It's an odd situation. Mine was tested at Cornell, actually, to see if he was deaf as a puppy, because that's the thing, I guess. But any questions? All right, so again, we're just manipulating percentages and solving given certain information. We'll get more complicated, don't worry. Like this one, well, I guess the next one's more complicated, but so the sales tax in Erie County is 8.25%. I think it still is, I don't know. If a laptop costs this much money, it's kind of expensive. I'm assuming it's a MacBook. How much does it cost after tax? So there's a couple ways you can do this. There's a quick way and then there's a not so quick way. They're both kind of short, but the one way you can do it is you can just first find how much tax you're going to add on, right? So I can find what 8.25% of that $15.99.99 is, and then I can add that back on. Right? We'll do that first, but then I'll show you kind of a shortcut that some people like. I guess I would prefer it that way. All right, so I'll do it this way first. So I'll just find 8.25% of this number and add it. So 1599.99, and then I'll multiply it times 8.25%. And this is just like, this is part over whole equals the percent. So I'm using the same technique that we used for this Dalmatian one, right? Whole number of Dalmatians times the percent. Here, instead of population of Dalmatians, it's the amount of money, and my percent is the tax rate. But it's the same strategy. I'm not doing anything different. And just like before, I need to convert this to a decimal for my calculator to understand it. So 1599.99, and you can put dollar signs if you're so inclined, and then times 8.25. And so again, when we go from percent to decimal, I divide by 100. All right, so let's see what we have. I need to put something under my desk. It keeps shifting. Sorry about that. So 1599.99 times 8.25, and then divide by 100. It shouldn't matter here. This should be fine. So about, I don't know, 131, I'll say 99. I'll keep it like that. Okay, so that's my tax. It's expensive. MacBooks are expensive, but they're so good. I would recommend a MacBook. I have to use this PC thing. It's terrible. It's horrible. I can't. Anyway, And to get so now it says, how much does it cost after tax? And so when people say, how much does it cost after tax? They want the whole, what you're going to pay at the counter, right? So I'm going to take that tax, add it to my initial cost, or whatever the sales price of the laptop was. So total cost, total after tax cost. So it's going to be, let me try to censor this. There we go. 1599.99 plus 131.99. And I don't know what that's going to be, but let's see. Plus 1599.99. Survey says 1731 and 99 cents. So pretty expensive. That you could probably buy a car for that much. Not a good car, but a car. All right. Now, let me show you another way to do it, which is faster. So so what do we do here, right? So I added the 1599 and the 131, right? So let me write that. So I have 1599.99, and then I added the tax, all right? So the tax, we got this 131.99 number by multiplying 1599.99 by the tax rate. So I'm gonna write that instead of the 131. So it's gonna be plus 1599.99 times, I don't know, I'll leave it as 8.25%. Right, so that's what it is, right? And so what I can do is I can factor out the 159999, 159999, so many nines, but that's retail. And I get 1 plus 8.25%, all right? So what is 1 as a percent? Right, so it's like a decimal. So to convert it from a decimal to a percent, I'm going to multiply times 100. And so 1 times 100 is 100. And so all as a percent, this is 1599.99. And then 100% plus 8.25%. And now, since they're both percents, I can just add them together. So I guess that's something to keep in mind. You can't add things together if they're not both percents or both not percents. So you can write these both as percents, or you can write them both as decimals, and then you can add them then. But unless they're both in the same kind of standard, you can't combine them together. Not easily, I guess. Regardless, I get 1599.99 times 108.25%. All right. And so that's a really quick way to do it. Doing it this way, you don't have to add anything. I can just, and you can even write it as a decimal to make your life better. So it's just 159999 times, and if I wrote this as a decimal, I get 1.0825. All right, so we can see if that works. So 159999, oops, times 1.0825. So I get 1731 and 99 cents, just like we did before. All right. So a really quick way to do these problems. So you don't have to like compute the tax and then add it on after. You can just do it all directly in one computation, right? But either way will work. So any issues there? Okay, it's kind of a fun one. Let us continue on our journey into percentages. All right, so this one is a little more tricky. So you bought a muffler at a flea market for an after-tax cost of $256.12. First, I don't know why you're buying mufflers at a flea market. That's the first question. And two, I don't know why a situation would arise wherein you only know the after-tax costs. That seems very sketchy. It is a flea market, so it's kind of prone to sketchiness. But I don't know. Has anyone ever been to the Super Flea in Buffalo before it closed?
No.
You're the Super Flea in Buffalo was a glorious place. It was the sketchiest place. All these little stalls, and you go in, and like in the back, there's like a used rim salesman, and then there's like a leather store, and you could buy like old video games on the cheap, and just the weirdest people. And then there was like a little food stand where they sold hot dogs and hamburgers. It was a beautiful
That
thing.
sounds extremely familiar.
The Super Flea, it was huge. It's now a Walmart, sadly. It's the most depressing thing on the planet.
I mean, I don't remember specifically going there myself, but I
Mhm.
easily could have gone there when I was younger and my mom, like my parents brought me. Because
Yeah.
explaining it sounds extremely familiar.
It sounds kind of sketchy.
It was so fun. I used to go as a child and buy video games. It was great. I miss it. But I mean, eBay kind of replaced it. Well, you just go on eBay now. But anyway, so this is kind of that situation. We're in a sketchy flea market in Buffalo. But so my after-tax cost, after tax, is $2.56 and 12 cents. And the tax rate's the same because it's in Erie County still. Even though it's Cheektowaga, it's still Erie County somehow. And so how much does the laptop cost before tax? What you want to do is you just want to set it up, right? So the way you'd compute it in general, like I did before, is I had the pre-tax cost, right? And I'm going to do it like I just did on this, that blank sheet of paper I threw on the floor. I'm going to do to compute it, I'll do the pre-tax cost times 1.0825 equals after tax cost. All right, so this is basically my equation, right? This is even if I knew nothing about the cost, this is how I would compute the after tax cost with this tax rate. All right, so in the previous problem, we knew the pre-tax cost and we wanted to compute the after-tax cost. Here, we know the after-tax cost and want to know the pre-tax cost. So all I do is I plug in the after-tax cost here and then solve for it like it's just an algebraic equation, right? So I plug in 256 and 12 cents for the after-tax cost. So I get pre-tax cost times 1.0825 equals 256 and 12 cents. And as I said, we can solve it like an equation, like this is just my variable. And so what I can do is I can divide by that 1.0825 on both sides to solve for my pre-tax. So my pre-tax cost equals 256 and 12 cents over 1.0825. All right, and then obviously you need a calculator because that's ugly. So 256 and 12 cents. Oops. Divided by 1.0825. Bam, what do we get? 236 and 60 cents. So 236 and 60 cents. So my pre-tax cost is about 236. My after-tax cost is about 256. Right? So you can go back and forth. So if for some reason ever you buy something at like Kohl's and you need to know what it costs initially, you have to know the exact tax rate. I don't know what it is in Cat County, but you can do the same process. So if the tax rate in Cat County, I think it's probably lower. If it's like 6 3/4 or something like that for percent, then you would just divide it by 1.0675 if that was your rate for some reason. All right, but any questions? Right, so it's kind of cool. You can go back and forth. And this, I have seen this before in, I have had to use this in like a real life situation. I can't remember what it was, but it's come up before. It's good to know. All right. So let's, oh, we have a thing. Wait just a second. Chat. Sorry. Oh, no worries. It's okay. Everything's posted online. So we're all learning. All right. So a lender requires a minimum down payment of 12% on the value of a home. You have some odd amount of cash available as a down payment. Determine the maximum home value that you can finance. Right? So in this case, you're like taking out a mortgage, and this is your down payment. 12% is generally a low down payment. I think generally they advise 20%. I think anything less than like 8 or 4 or something, you have to get mortgage insurance. It's a whole thing. I wouldn't advise it, but in this case, it's just, I guess it's just no mortgage. So let's see. So determine the maximum value, right? And so this is the most we have, right? That's the most we can spend. And so we want a maximum value. So what we're going to do is we're going to pretend that we spend all of that on our down payment. And our down payment is 12%, right? So it's just like the problem we did, but in terms of houses instead of sketchy mufflers, right? And so I'll write it out in this equation. It might be easier to see. So maximum value, max value. So the max value times 12%, I'm going to assume is my down payment. Right. And maybe I'll say maximum down payment. Oh, sorry. Does that make sense? Right. So the most I can put down will correspond to the most I can spend on a house. And so if my max down payment is exactly the available cash I have on hand, I can plug that in. So this is equal to $22,020. And that's still equal to the max value times 12%. So if I want the max value, I can just divide, just like in the muffler one, I can divide by that 12%, right? It's a little different, I suppose, because in the previous one, we were doing taxes. It's a little different because there was like 1 point whatever, but now we're just doing 12. So it's slightly different, but the method's the same. And so I just divide. So my max value equals this number, 22020 divided by 12%. And again, whenever you're doing calculations on your calculator with percents, you need them as a decimal. So to go from percent to decimal, I divide. So I do 22020, and then I'll do 12 divided by 100 to get 0.12. So it's over 0.12. Let's see, that's gonna be a decently large number. That's gonna be a huge number. 22020, oops, divided by 12, 0.12. It's big. It's a big number. 184,000. I'll leave it as what it is though. 183500. Right. So that's the most you could spend on a house, assuming you were spending 12% on the down payment. Now, what if you had to spend 20% on the down payment, right? As I said, I think most mortgages want you to spend 20, at least maybe it's advised, I don't know. So we'll try that. So 22020 divided by 0.2, and I'll be 0.20. So if I wanted to put 20% down, I would only have a maximum payment of 110, or maximum house value of 110,000. So, going from 12 to 20 really decreases the value you can spend on a house. All right. So any issues there? And I think, so in the next unit, actually, we'll do a lot more of this. So in the next unit, we talk about things like savings plans and credit. I think we talk about credit cards. It's basically exponential growth. We talk about credit cards, interest, what's the other thing, and mortgages. So we talk about a lot of this stuff later on too, in more detail. We have kind of more precise formulas and stuff like that. So if you like this, there's more to come. If you don't, I apologize. It's only one more unit though. Let's see. All right, so questions with percentages in this context. We good? All right. So so that was 4.1 and 4.2. 4.1 is really short. It's just like a little booper introducing percentages. 4.2 is more of a meaty chapter. And then 4.3 is about this absolute and relative change, which we did the beginning of this when we talked about exponentials because we needed relative change to talk about exponential growth or decay. But now we're going to kind of talk about it in a little more detail, right? But this is the definition, at least, is review. So given a quantity that has experienced some change, we can study how the quantity has changed in two ways, right? And we did talk about this. So the first one is the more naive way. Ending quantity minus starting quantity. So it's just literally how much did it grow? So if it's 50 degrees today and 70 degrees tomorrow, the absolute change, which is what this is, the absolute change is 70 minus 50, or 20 degrees, right? But sometimes that's not a great way to see how things are going, right? If the temperature goes from, I don't have examples, but sometimes you want to know how much it's changing relative to the quantity itself. So what would be a good example? I guess temperature is not a good one, but I guess suppose you have like $1 million in investments and you lose $200. Like relatively speaking, that $200 is not a lot compared to the million. But if you only have $1,000 in your investments and you lose 200, that's a fifth of your total investment. So it's a much bigger chunk. And so you'd be more concerned about losing $200 than if you had $1 million. So sometimes the absolute change doesn't really tell you enough, but the relative change will tell you more relatively. It'll tell you more about how much you're losing or gaining compared to how much you have, essentially. And so that's why it's the absolute change. It's how much the quantity literally changed over how much the quantity was initially, right? And that's what I mean. So like for the relative change, if you had $200 and you had, or if you lost $200 and you had $1,000 in your account, you would have 200 or minus 200 over 1,000. So your change would be what, minus 20%. But if you had 200 loss over 1,000,000, it'd be much teenier. So it's different ways of looking at the same thing.
Did we do this with population?
We did. As I said, we had to talk about this when we did exponential growth, because to talk about exponentials at all, you really need relative change. And so I kind of went here and then talked about a little bit of it and then went back. Yeah. But since we're doing it as like a unit at this point, I want to just kind of cover it again. Yeah. I know I don't like how the book is set up in that way. I don't understand why they put exponentials and linear stuff right at the beginning before you've talked about percentages. It doesn't make any sense to me, but I didn't make it. All right, so let's look at some examples. And again, these seem familiar. We didn't do these little ones because I just wrote them up, but we did ones comparable. You buy a baseball card for $30 in 2010. And this year, in 2020, you sell the card for $45. What is the absolute relative change? So let me just write down the two, absolute, relative. So the absolute change is literally just how much you gain or lose. And I should note, they can both be positive or negative. You can have absolute growth or absolute change that is negative, and you can have relative change that is a negative percent. Nothing wrong with that. So if you're doing problems like on the homework, which I haven't assigned yet, and you get a relative change that's negative, that's okay. Just like in the population project we did at the beginning of the semester, you can have a population whose relative change is going down because the population is decreasing. All right, so anyway, what is the absolute change for this one? It was 30 and it went up for $45.
15.
Yeah, right. So you just do 45 minus 30. So that's 15. Right. And so the relative change is just the absolute change over the starting value. Right. Or starting quantity, doesn't really matter. So it's gonna be 15 over 30. Right. And so obviously that's 1/2. What? Yeah. Yeah. I had a brain fart, I'm sorry. And so that's 0.5, right? And as a percent, which is really, so whenever you talk about relative change, you generally want to talk about it as a percent. So there's nothing wrong with writing this as 0.5 or 1/2, which looks kind of funky. But as a percent, it makes more sense. So as a percent, this is just 50%, of course. And then in the context of the problem, it kind of works better, right? So what this is saying is that the change from 2010 to 2020 was 50% of the card's value in 2010. So you take 50% of the 30 and add it on, and that's what the card's value was in 2020, right? So when you're reading relative change, that's what it's talking about. You're changing with respect to some percentage at some time. So 50% of the initial, you add it on, that's the growth. And I also want to note that the years here don't matter, right? It doesn't matter. I don't care how long it took for these changes, for these kind of, study of change. It doesn't matter what the time is. Time is no factor here. So if you see a problem like this asking for absolute relative change and it gives you years, it doesn't matter. Don't do like a slope. You might be tempted to do like a slope kind of situation. Don't do that. All right. Another one. 2008 Honda Civic. I had a 2008 Honda Civic. It was amazing. It was a good car, and he was destroyed tragically. And it'll be 2 years this November. It's very sad. I might have a memorial for him. But he was T-boned. It was really bad. It was my fault, but I feel bad for him still. Anyway, I have a new Civic, and he's not as good. He doesn't have knobs on the stereo, and I have to touch this. It's horrible. I hate touchscreens on cars. I can't see them. I can't feel what I'm doing. It's not good. Anyway, It's
My
2000.
radio in my car is touchscreen, and like right above the change song is a button that like turns the screen off. So I'm constantly turning the screen off when I'm trying to change my song.
I hate it. Me too. I'm like on Chapel Hill and I'm like trying to get something and I'm like almost off. It's not good. I hate it. My old car had these little knobs. I could feel what I'm doing. I don't think they really thought about with the touchscreen, but it's whatever. It looks nice, which is I guess the selling point. So yeah, 28 Civic was worth 10 grand in 2012. Again, the years here won't matter. In 2018, it was worth this much. Again, absolute relative change. Let's see. So I'll write down apps, relative, all right, doesn't matter. So the absolute change again is just how much it changed. So the starting value, I guess the only reason you need the years, I put the years here, was to give you an idea of what the starting, what the ending value should be. So it was worth this much in 2012. And later, so this is the starting. And later in 2018, it was worth that much. So this is the ending. So I'm going to do the ending minus the start. So I'm going to do the smaller, 6, 4, 3, 9, minus the start, 10, 1, 2, 3. And as I said, it can be negative. So this is an example where you'll get a negative absolute change and a corresponding negative relative change. So I do what, 6, 5, 3, 9, minus 10, 1, 2, 3. So I get minus, and it's dollars, so you can put dollars here, 3, 6, 8, 4. Right. So it's a car, so it depreciates in value as time goes on and wears out. His name was Henry, and poor Henry's AC system died one time, and that was expensive. It was bad. I'm sad he didn't get to fully use his new AC system. I think he died shortly thereafter. But anyway, so now for the relative, just like up here, it's going to be absolute over starting. And you probably want to write it as a percent. I'll do it as a decimal to begin with. But my absolute change was that minus about 4 grand, minus 3, 6, 8, 4, over the starting, which was 10, 1, 2, 3. Okay. And let's see what I get. It's going to be ugly, so you will need a calculator for this one. So 3, 6, 8, 4 divided by 10, 1, 2, 3. Something like that. So maybe I'll put that minus 0.36, and then times 100. So about minus, and again, you can round to whatever you like, about minus 36%. Right, as a percent, it makes more sense, right? So the way you can see it really quick is that the car was initially worth about 10 grand, right? And over these period of years, it lost about $3,000 worth. Well, I guess $3,600 worth of its value, right? So if it was worth 10 grand and it lost about 3,600, that amount is about 36% of the 10 grand. So whenever you're doing these problems, you should always kind of do a quick check and be like, oh, does it make sense that I'm losing 36%? Now, if my starting value was 20, or maybe I'll make it more, if my starting value was like 50K and I lost 3 grand and I computed this, I found that it was only 36%, there'd be a problem, right? Because 30% of 50K is not 3,000. So it kind of makes sure that it makes sense with a quick eyeball check. But it shouldn't have any problems. If you do, that's okay though. All right. Oh, so this is what the one weird thing, my chair is falling. This was the one weird problem that I mentioned earlier, like linguistics. So it's kind of just an aside. It's not terribly important, but if you talk about percentages, it is. So politicians' support increases from 40% to 50%. Describe the change. It's not a hard problem. But you might be tempted to say his support went up by 10%. You can't really say that. So you don't say support went up by 10%. Right? Because what does that mean? Right? 10%. Like it's not clear. You don't know what his support was. Like, are you talking about 10% more voters than he initially had? Are you talking about like like these 40 to 50? Like so like if you're just trying to say that, you know what I mean? So what's 40? So 40 times 0.10. So it's 4. So like, are you trying to say he gained 4 percentage points? It's not clear. So you don't want to say something like that unless you know like there's some metric wherein his actual support went up by 10%. So for instance, something where you might say this is if he had 100 supporters, maybe it's like a very tiny local election, he had 100 supporters and the next day he had 110 supporters, then his support would go up by 10% because he gained 10 supporters, which is 10% of what he initially had. So you could say that in that situation. But here we're dealing with like the actual percentages. And so when this arises, what you want to say is that he gained 10 percentage points. All right, so that's what you would say. So these, that's what they call them. Just to kind of remove this ambiguity, they'll say these are percentage points. All right, so you could say like this is 40 percentage points. No one says that, but you're referring to the actual points of percent as percentage points. Right? So it's just a very tiny note, but it's important because there's a lot of confusion otherwise, especially if you're talking about things like that. Any questions with that? All right. All right, so that was just an aside. We're kind of back into it now. All right, so this one is a little funky and it kind of skirts close to that exponential stuff we did. But you have $1,300 on a credit card. The credit card accrues interest at 22.5% annually every year. All right. If you forget you have debt, I don't know how that happens. And for 5 years and pay nothing, again, I don't know how that happens. You just like ignore the bills coming in. I guess if you don't have the money, that's fine. How much will you owe? All right. So the idea is that you start with 1,300. So 1,300 is my starting value. And every year I gain this 22.5% interest on my value. So what we're going to do is we're going to make a little table, all right, and see how much we owe at the end. I guess I should make like a kind of line. So this stuff above that we just did, and the relative and absolute change, that was just that little section. This is just some more applications of percentages from here on. Yeah. Right. So I'm just kind of play around with percentages for a little bit. As I said, this is mostly review, and then the next class we'll start with some newer stuff, I think. Right. Anyway, so I'm going to make a little table. So I'm going to say this is year 0. So maybe I'll put year, and then amount. So at year 0, I owe 1,300. That's exactly when I maybe charged it. Maybe I bought, I don't know, a MacBook Air. I think that cost about that much. Maybe I bought that and put it in a credit card, forgot about it, and now I still owe the money. Every year, 22.5%. I think that's high for a credit card, by the way, but it's not out of the question. And so what we'll do is we'll do it just like we did before for the tax. So for the tax, remember, I multiply by 1.0825 to add 8.25% tax on. I'm going to do the same thing for the interest. I'm going to multiply by 225, and that will add the interest on. So maybe I'll make a note. So note. So I can add the 22.5% interest by multiplying by 1.225, right? I think it's the same reason that we did before. It's 122.5%. So you're taking your initial value, the 100% corresponds to the fact that your 1,300 isn't going anywhere, and you're adding on that 22.5%, right? And then we'll just kind of iteratively do this. The first year we'll do it, the next year we'll do it, and we'll do it for 5 years. All right, so year 1, let's see what happens. And if you have a TI calculator like this, there's a really quick way to do it. You can do 1,300, press enter, and then do times. And when you press times or any other operation without anything on the screen, it will assume you want your previous answer. So you press times, and that's what answer is. It's this one for now. And I'll do 1.225. And so that's my next year. So at year one, I owe $15.92 and 50 cents. But I want 5 years, so I'll make a list: 2, 3, 4, 5. And the thing is, you can press enter again, and what it will do whenever you press enter on your on this calculator, and I think it's true for like TI-83 and probably all the other ones, like that'd be something weird stuff. But for most of the ones that look like this, you press enter and it will repeat the previous command, but the previous command was answer times 1.225, so it will constantly take the previous answer and just multiply it by 1.225. So it kind of limits the amount of work you have to do to the barest minimum. All right, so I get 19.50 and 81 cents. All right, and we'll keep going. And so in the past, when we did this with exponentials, we did it all by hand for the exponential section. So, you know, doing it quick, I feel like it's acceptable. So 28 or 23.89 and 74 cents, 75 cents. Okay, so you see it's growing like crazy. 29 and 27 and 45. And one more. Oh, 35.86 and 11. Huge. 35.86 and 11. Right, so it's just an astronomical amount of money, right? You only initially paid $1,300, but with this wildly high interest rate, you're adding on basically a quarter almost every year, right? And so, yeah, I think again, this 25.5 is really high for a credit card, and most of them don't make you pay interest right away anyway, so it's usually not a problem. But you might find like this kind of high percentage rate on the, what do they call those loans, the like high risk loans kind of thing, money payday loans, the ones that are really shady. You'll find interest rates like that in really shady loans, right? And as you can see, this is the danger because they blow up like wild. Any questions?
When
Right.
you're investing in like penny stuff,
Yeah.
it's a high risk, high return. So you have like interest rates like that, but you also have the risk of everything in a blink of an eye.
Well, yeah, exactly. Yeah. So hopefully, if you're doing something with this high of an interest rate, there's a benefit to you. So like with those penny loans, like you said, you might make a lot of money, and then with these other loans that I'm thinking of that are sketchy, the money's accessible right now. Like it's immediate. So you know there are hopefully benefits, but sometimes it's sketchy. All right. All right. Let's do a couple more. Let's see. So again, as I said, these last few, this is the last one actually. These last couple are just kind of more applications. So let's see. So a TV originally priced at $999.99, that's the thing people do, is on sale for 40% off. Determine the sale price of the TV. So let's do that, and then let's do this. So and determine the final cost, final after tax cost. If tax is, I don't know, we'll change it up. We'll say 9.75%. Maybe we're like in, I don't know, California or something. I feel like they have high taxes, right? That's what people think. All right, so the first thing we need to do is take this 40% off the TV because that's done before taxes, right? So basically you just cut off the 40% and we're good. I don't know if we've talked about this. How do anyone know how to remove 40%? I guess we can do it like taxes. So the direct way that I feel like most people would do it is you would compute 40% of $999.99 and then subtract it. And that's fine. So we'll do it that way. So I'll do, so the amount off. So the amount off, I'll do 99, 99, so many nines, and then times 40%. All right. So let's see, what does our calculator tell it is? 99.99. And then don't forget, again, 40% means 40 times 1 over 100. So that's just going to be 0.4, but you can also do 40 divided by 100. So you get, that's a decent amount of money. And that makes sense, actually, right? This is about $1,000. 40% of $1,000 is $400. It's about $400. What can you do? So it's a huge discount. So it's $399.99. We don't usually talk about fractional parts of pennies unless we're like at a gas station for some reason. I don't know why that's a thing. So that's the amount off. And then what I'll do is I'll just subtract it. So new price is 99999 minus 39999. And what are you gonna get? You might just know by looking at it, right? But you can do it in your calculator too. It's $600. That's kind of pretty. The new price is just a flat rate of $600, which is decent for a TV. Actually, I've never bought a TV. Actually, the TV I used to have was given to me. And the new TV came with a house. So I don't know. I don't know what TVs cost. Anyway, now I want to. So that's my new price. So this is the discounted price. Discounted price. And now to add tax, we just do it like we did before. So to add tax, so after tax. So after tax, I'll do 600. And then I'll do it like 100% plus 9.75%. So this is the way I did before. And once I'm done with this problem, I'm going to show you a kind of general format to doing this kind of thing. So what do I get? I get 600 times 109.75%. Converted as a decimal, remember percent to decimal, you divide by 100. So that's 600 times 1.0975. And whatever that is, let's see, 600 times 1.0975. So it's about $658.50. Okay, so after tax, that's what you get. All right, so let me look at this problem a little differently though. So any questions there so far? So this is always okay. When you're doing problems like this, feel free to just do it in steps. You don't need to do it all at once. You don't need to do it very fancy. Just do it whatever way works best for you, right? And I think this is like the simplest way. But if you want it to be fancier, instead of computing the amount off first and subtracting it to find the price, you can do it one step. So what I'll do is, alternatively, what I can do is I have $600, or sorry, I have $999.99, and I'm going to take the 100%, and my discount is 40%, right? So I'm taking off 40% of the 100, so minus 40%. And so it's the same kind of idea with the taxes where we're adding to add an additional percent, but here we're doing a discount. So we're subtracting off some percent from the whole, but it's the same process. It's just kind of the opposite direction. And so now this is 99999, and then it's just times 60%. Right? And of course, that's just 99999 times 0.6. And so in your calculator, I can do 9.99 times 0.6. And we rounded a little bit. So that's why it looks different here compared to what I did, because I rounded here when I computed it. So, yeah. But it's all good. So it's about the same. So it's 59999. All right. So that'd be a quicker way to do it. You take this is the whole, and you're subtracting out 40%, and so the remaining is 60% essentially. Right? If you were really fancy, you could do it all in one step. So taxes and discount, and it should work. We can try it. Let's see. I've never done this before. 99999 just occurred to me. You have 100%. You subtract off the discount of 40%. and then you add on the taxes. So this is discount. I hope this works. This is the original. So this is the, I don't know what I'd call this. This is like the sale price, or this is just the price. And then this is the tax. What was it? 9.75. Yeah. All right, so let's see what happens. So this is 60 and then 69. So it's 999.99. It should work. So it's 69 and 75%. Okay, so let's see, I'm very interested. 999 times shows me 0.6975. That's not what I got. That is different. See, be a little bit careful. Oh yeah, so that doesn't work. And here's why. So this is also a good lesson. So, so every percentage has a reference value. So for instance, when you're talking about like a class of students, like in that first problem we did, you have, 30% of 26 students, right? And that's some number. You could do 50% of 26 students. Again, that's like what, 13. So the percentages reference a number, the whole. And so here, the tax, the discount, and the price are referencing the whole. And so when you do it as when I try to do it as one step like this, what happens is that the tax is referencing 9% or whatever of the whole 99999. In contrast, this doing it after I do the discount, my 975% is referencing the 600. And so that's why I expected to get 568 or 658, but instead I got 697. So you got to be careful, like I wasn't. Try to get ahead of myself. All right. Anyways, this doesn't work. Just this last part. This first part's still fine, obviously. You do the discount, it's just 60%. But just be careful. You can't do the tax along with the discount for that reason, because it's referencing, you're doing tax on too much money, essentially. Although I feel like some stores might do that for some context. Maybe you get the discount after tax. I don't think so, but I don't know. All right. So, oh yeah, and I want to, before we end, we have like 10 minutes, but I won't go all the way end. The one thing, so note, this is if these last two examples are going to teach anything, this is what's important. So to add interest or tax at a rate R, say capital R %. So you can do, maybe I'll say P naught times 100% plus R %. Right, so this is your starting value. This is 100%, and this is my rate I want to add. So again, so like this is like tax or like the interest. If I'm adding interest or taxes, I would put the rate there, and that's one way to do it, to find the after tax or after, interest rate. You do 100 plus the rate as percents, and then you multiply it times your starting value, and that will give you the new value after you added the tax or the interest rate. Now going the other way, so this is the one way. So this is to add to reduce a price, or to reduce a price by 8%. Say percent rate R %. So this is like the discount. So you're going to do P naught 100% minus R %. So this is the starting value again. Starting value. All right. So it's very similar formulas, right? 100 plus R % or 100 minus R %. This one, you're adding some percentage to a value. This one, and my notes are kind of weird, but this one you're adding some percentage to a value. This one you're subtracting some percentage from a value. So whenever you're trying to do those two things, these are two quick ways to do it. But as I said, you can also just do it step by step. You can first compute the discount and then subtract it. You can first compute the tax and then add it as 2 steps. But if you want, you can also do it this way, where you're doing it all in one step by adding or subtracting from 100. All right. So I'll post some homework. They'll use all of this. I think these 2 things will come up a lot. And then just like with the laptop and the muffler, where you need to know the before tax based on the after tax, you'll have to do things like that too, where you basically just divide by the interest rate or divide by that rate. But we'll do more of these a little bit next class, and then we'll kind of get into some new material about finances, I think. But any questions? All right, so I'll end it there so we can all go eat dinner. I'll see you Thursday. If you have any issues, let me know. If you need to Zoom at all outside of like normal whatever hours, just let me know. I can, if you want, if you're only free on like Saturdays or something, just shoot me an email and we can set up a time. Or like on Sunday, for instance, if you don't work on Sundays, just let me know. And you know, we can arrange different times outside of my defined hours. All right. So anything that will work for you guys. So, okay, ciao.
Matt,
Gary,
hello.
how you doing, Gary?
Pretty good. I was trying some stuff